Okay. Hello, everyone. A warm welcome to this Rocket Mine and Straios webinar. Today, we'll be talking about using geotechnical AI to maximize safety and conformance. I'm delighted to be joined by Ravi Sahu, the CEO of Straios, on today's call. Ravi will shortly be giving a detailed overview of the exciting features, benefits, and additional details on the geotechnical AI module within the Straios platform. Within the Straios platform, we're not just focusing on the geotech AI. Straios includes drill and blast AI, fragmentation analysis, etc. But for the purposes of today's webinar, we'll be focusing on the geotech AI module. We are arranging a webinar to cover the drill and blast AI in March, and additional communication to sign up for that webinar will be distributed shortly. Next slide, please, Ravi.
Sure.
Okay, it's not showing up on my side. There we go. Okay. So a warm welcome again to everyone online, and I'd like to welcome and introduce other members of the team who are on this call today. As mentioned, Ravi Sahu is the CEO of Straios. Ravi's based in Buffalo, United States. We've got Kwadwo Aduro. He's our business development lead for West Africa, based here in the Rocket Mine Ghana office in Accra. Hanu Lombard, he's our business development lead for Rocket Mine South Africa, based in our Rocket Mine office in Johannesburg. AJ Harduth is a director for Rocket Mine South Africa, also based in Johannesburg. Cameron Fafarot is our managing executive, also based in Johannesburg. And myself, I'm Barnaby Martin. I'm the GM for Rocket Mine Ghana, based here in Accra. So again, welcome everyone to this webinar. I hope you find it interesting. As always, please post your comments in the bottom right-hand corner of this platform. We will have a Q&A session following Ravi's presentation today. Next slide, please, Ravi.
Yep, there you go.
Okay, I think there's a little bit of a lag on my side.
Yeah, perhaps, yeah. It's give it a maybe you can just continue, I guess. You know the slide.
Sure.
Yeah.
So before I hand over to Ravi, I'd just like to give a brief overview of who we are as Rocket Mine. We are ranked Africa's #1 drone data solutions provider by DroneEye. We have operations in over 12 countries on the continent, with offices in Johannesburg, South Africa, and also Accra, Ghana. We have the largest fleet in Africa, with over 120 plus enterprise drones, and we're part of the Delta Drone Group, who are listed on the ASX in Australia. Next slide, please, Ravi. Okay, so in addition to the services that we provide in the mining space, be it from a survey aspect, high resolution pit scans, high wall mapping, we have our underground LiDAR solution as well. But we're also involved in other industries, be it the construction space or agriculture. We also have our security and surveillance solution, and we've performed inspections in the oil and gas space, power line inspections, and also solar farm inspections. We have our in-house drone training school, DSL, Drone Safety and Legal, in collaboration with the University of Pretoria. We offer a comprehensive range of courses, RPL, BVLOS, dangerous goods, CRM for RPAS, etc. We're SGS fully accredited, and we're BARS audited. Next slide, please, Ravi. Okay, so RocketMine provides geospatial and AI data solutions from mine to mill and beyond. So we're involved in the exploration phase, providing data, survey and planning, geotech space, drill and blast, tailing storage management, for example, with our thermal leak detection solution. For the purpose of today's webinar, we're going to be focusing on the geotechnical aspect. And you'll see here items highlighted in blue are the AI-enabled features. So in the geotechnical space, you've got the AI crack detection and the haul road conformance aspects. So I think this is a good point to hand over to Ravi for a more in-depth overview of the Strauss platform. So Ravi, over to you.
Thank you, Barnaby, for the introductions and the overview here. And welcome, everybody. It's great to meet you all. And I'm excited to talk about a few things, more high-level understanding of how AI can play a role in geotechnical analysis and design conformance. We may not be able to cover everything that encompasses this topic, but in the limited time today, about 40 minutes, we will cover as much as some of the important day-to-day operational geotechnical analysis that can be solved using AI. So
Sorry,
quick
Ravi.
introduction. Yep.
Sorry, just to interrupt there. There's a few comments here. The slides are not visible on their side.
Okay. Okay. Let's try this again. Okay. Let me share my screen again. Is it visible now?
I can see now.
Okay, I'm making a full screen. Is it better now?
I can see on my side.
Okay. Yeah, just type on the chat box if you're having trouble seeing the screen. We'll flip through this again. All right, so I'll keep it going here. So just a quick introduction about Istreos. What we have as a platform is AI for mine to mill. The company was started back in 2016. So since then, we have grown into 25 countries and roughly 1,500 sites use our platform, spanning across 80 plus customers. We have a global presence in terms of the team, where teams across in different regions, Asia, Europe, Australia, and America, where the headquarter is. So that allows us to do a 24/7 support. So if you have issues, there will be someone to cover and address your issues. Since some of the milestones that we have gone through as a platform is, roughly more than 100,000 projects in the platform, 50 million imagery analyzed, and we focus a lot more on the operational side of the things. So we'll cover more on that on the geotechnical use case today. But as a platform, when I say mine to mill, we start with the first step, which is surveying and planning, more on the production side. So we have in our own photogrammetry engine and a LiDAR data processing engine where you can bring your data and it can process and generate georeference 2D and 3D models. And from that same data, variety of analysis can be done automatically, such as rock mass characterization, and then full suite of drilling and blasting design, and the prediction tools are built in, and, tightly coupled there. On the prediction side, we have fragmentation, muck pile simulation, as well as the ore dilution prediction types of tools are there. Then after the drilling and blasting phase, the pit analysis side, the loading and hauling use cases are built in on the analytics side. Post-blast side, again, fragmentation analysis and muck pile movement analysis are built in as a part of the value chain. So overall, it does is it brings the data in one place, and you can see the KPI reporting. What is your cost per ton? What is the different KPIs that you are trying to measure on a quarterly or a yearly basis that can be easily tracked in one place? So that everything that I touched upon is more on the pit side, which means your active mine. Then we have a solutions on the mill side, which is related to the real-time gradation or the particle size detection at the truck passing or the conveyor or crushers, and then also at the shovels as well. So this allows to monitor the ore content at the various stages in the crushing and milling process. That way you have a continuous analysis of the combination, flow here. So
Ravi,
once,
sorry
yes.
to interrupt there. The slides don't seem to be moving. I'm still on the A to I, mine to mill slide.
Oh, okay. That's strange. Seems definitely there is a lag here. Is what I may do is I'll just I won't do it a full screen and just move it. Just move it kind of just without a slideshow here. So that's makes it easier to move here
Yep,
because
it's
since
moving
like
now.
this, yeah, yeah. So I think uh, yeah, I'll just skip this. But in terms of where on the mill side of the things, where we also address solutions where the ore content can be monitored real time. And once you have the data, that data can be passed back to your day-to-day design operations as well. So this allows to close the feedback loop that is needed to optimize the operations. And that's why we focus on the mine to mill optimization of the process. So for today's session, here is the agenda where we will do a quick introduction for the topic. We'll talk about kind of the evolution of survey data collection and how we can leverage geospatial data for AI that you're already collecting, and what are the challenges that comes in the design conformance side, and how AI can be applicable in the geotechnical AI here and some design conformance analysis examples here. So we'll continue here. Hopefully the slides are moving in a proper flow now. If you still have issues, just let me know. So we'll start with the evolution of survey data collection, and everybody has a different level of maturity in the site. Some sites are well advanced; they've been using high advanced laser scanning or radar or autonomous systems to collect the data, or some sites are just getting started. But there are tools out there readily available that can be utilized now to capture as-built data more frequently than ever. The sensor technologies, such as drones, there are handheld lidars as well, and now the hyperspectral cameras are also becoming readily available to collect this data. And what it allows is it allows to collect this rich geospatial data more frequent, more faster, and easier. And that is the whole premise here. That if you are able to collect the data on a daily basis, or you know, as your operations are changing, that is a powerful source of data that you can utilize to make the operational decisions or mine plan decisions more on a nimble basis and more on an agile basis here. But how do you handle this data? Because these data sets are not easy to handle. You need almost a team to analyze this data on a daily basis, uh, to um to to structure this data, as well as pass on some decision metrics, from this data set. So that's where a lot of the other issues that comes in, which means mines are capturing already a lot of data from surveying, but it cannot be turned to a real hard cash benefits, which in other terms, it's, the ROI. We can have a data, but it becomes only useful just as a survey data, but not the decision intelligence or the business intelligence that we are looking, or at least operational intelligence. And that's what we're going to focus today. Um, so how do you leverage this data, the geospatial data that you are generating here? And and the AI is a perfect example where it can be embedded, and the models can be trained to look for scenarios, to look for this uh, opportunities where the data just sit, because somebody has to go and spend hours and hours to understand. Now that those things can be easily identified, through the applications of AI. But it's important to really talk about the maturity curve of AI in mining, because what is happening here is the mines are the perfect candidate to generate this data, and AI is a perfect also a candidate to apply in this data set, because it's repetitive, plus also it's once the domain knowledge is there, the use case that gets implemented from AI can become very focused in identifying those intelligence that we are looking. Um, so that's where the true understanding from where my geospatial AI data is can help understand, if I am looking from a geotechnical perspective, how does that correlate the mine planning? So now we can build a contextual intelligence from not only from like what we are looking, but also why we are looking. And we can break down the different data silos from a complex enterprise, to a streamlined enterprise. And what I mean by that is, if we know already a step ahead the issues on a daily basis or on a weekly basis, the geotechnical issues, how that will impact my mine planning well in advance. Now I can break it down easily, the different steps that I need to take well in advance. So, diving more deeper here, what is geospatial AI? So, geospatial AI is nothing where you're capturing the data as built data in a form of imagery, lidar data, or a scan data, which has a geospatial context to it, which means each data can be referenced to another positional information. And that's where the power of relational information can come in, which we will talk more in detail in the next few slides. But how does this works? Geospatial AI is, it's an analysis of each pixel, and each pixel, when you have it when you have that resolution, it can give a lot more information. And to parse through this information, the AI is a perfect candidate, where it can run several computations in a fraction of seconds and give you the results that you're looking for. So uh, there are several use cases to it, uh, but it does require a workflow implementation. It's not just kind of throwing the data and the AI will work, but the workflow implementation starts with having a proper data collection workflow, which means starting with either you have drones or any other aerial or autonomous scanning systems which are able to collect the geospatial data. And then you have that as a part of your operational process, which means either it can be a daily basis or a weekly basis, however you want to implement this workflow. Uh, and then once you have the data coming in, you can capture most of your sites are already capturing this data. But then the next step is the analysis of this data becomes very tedious process. It only stops at we have survey maps, and now what we're going to do with it. So either we throw in an AutoCAD, tools, or just CAD tools, which are very powerful, but it becomes another step process to go and run manual analysis and generate manual reports there. Or there is additional workflow can be built on top of this data that has been generated as an output to run this AI based analysis here, which can then compare to several surveys that you are already doing. And that becomes the relational information from survey to survey for any monitoring that you are doing, or any historical comparison, or the conformance reporting you're doing. So this kind of the workflow is now the workflow is you have the data, you have the processing done, and then you have a new ways of AI tools you can select to generate the analysis here. Just kind of how it can work is you get the data, you upload it, and you get the results, and then during the same time, all the information is getting processed as well. What it
Sorry,
comes out.
Matteo. Ravid, before we go on, I just want to confirm that the audience can see the slides, that they're moving as they should be moving. So my screen showing we're on slide 20 just now. That's correct, Ravi?
Yeah.
Okay. Okay, all good.
Yeah. Okay.
Thank you, Ravi.
Great. Yeah. So in terms of now you have the data process, but what analysis that can come out is also it's very important, right? And there are models that gets trained from all this data set that helps really automate some of the repetitive task that sometimes gets overlooked, or sometimes just doesn't get done because there is a lot of other important tasks out there, such as identification of area of interest where the crest and toe needs to be digitized from the as-built data. Now this task AI can do that. The roads, the rock edges, and the algorithms are also tasked to perform operational analysis on the engineering tasks, such as what's the high wall angle. You can set a tolerance, the grade distribution in the haul road, particle size distribution. But more importantly, where the rubber meets the road is like you're looking for report, right? And if you can consolidate all this information where you have area of interest, and then you have the engineering and operational analysis, and if you can have all this synthesized in one single report, that is a much powerful way to do the analysis at the end of the day, looking at the report, whether my tolerance or compliance is meeting in this specific area or not. I'm good. I can go and do my the next set of activities here, and then it builds the historical comparison. You can do a trend analysis automatically, whether the compliance is consistent in the sections, the high wall sections that we are gauging, or whether it's getting out of compliance as well, along with the site-wide summary. So we will we have a quick poll here, which will be good to understand from everybody from the audience here to see where how they do the geotechnical currently in their operations. So I'll kick off this poll if you can participate. I just launched the poll. It should be popping up in your screens. The question is, what is your current method of design conformance analysis?
So you can find the poll, the top right-hand corner. There's a little icon, polls.
We'll leave it open for another like 15 seconds here. All right, we'll close now. So very interesting responses. I think there's a lot of already software and tools has been utilized in the operations, which is great. Still the answers are coming, so we'll leave it open another 3 seconds. Okay, we'll wrap it up. Thank you everybody for participating here. Very interesting responses. Well, that brings the next topic here, which is a good segue from the last poll here. What are the challenges that comes in the design conformance here? And there are various challenges, not just in terms of the data collection, but the analysis is also a big part, what we are looking into here. Let's tackle one by one here, but I want to focus more on the problem side first. Why it's always a problem in maintaining the design conformance, which is the core issue, which is more from the operational side, nothing has to do with the data collection side. The major causes, that we always see the design conformance are not met is the way how the production activities are done. And the production activities are blasting or the excavation practices that has been carried out in the mining operations. Um, so that's one part, and that cannot be that can be controlled in some capacity, but it's always very difficult and challenging because there could be a geology issues, there could be environmental issues, there could be rock mass consideration issues. So a lot of the time, the blasting and excavation practices are not doesn't go and as exactly what has been designed in the mine plan to what has been done in the production, and that's why we do design conformance. So now, in order to do the accurate design conformance, we need a regular up-to-date data that we can rely on that can be compared with the as-built data as well. Regular issues that comes from the blasting side is the deviation of pre-split holes, insufficient hole depth, and that's that has always causes in the various floor issues as well. But more importantly, a lot of the errors that occurs in the blasting pattern, where the hole deviations occurs, which has either too much explosives or less explosive, that causes all these issues on the design conformance for the next high wall that is going to come in after that blasting. And then the next one is also excavation and scaling, which means mining too much or less material, and then also the improper scaling of rocks, which has a much more broader impact in the final pit walls. So overall, drilling, blasting, and excavation and dewatering activities mainly constitute at the implementation stage, such as mine design, planning. But in order to have a good design, the geology is always geology, blast design, excavation practices needs to be considered on a very accurate basis in the production. If not, if things doesn't go as planned or as designed, we do design conformance and the reconciliation. And the reconciliation brings a new set of opportunities to look at the data of what is non-conforming, to highlight areas of improvement for opportunities, to improve on the mine design, to improve the techniques, uh, such as minimizing the ore loss or avoiding kind of the pit stability issues that usually comes. So that's why the conformance is a crucial part of day-to-day operations. Uh, I believe here. Typical scenario that I've listed here, a couple of them, very basic ones, which is just the improper bench width. It can be easily overlooked, but it has a broader impact on uh, what on the design side and the mine as built. And if the bench width is not achieved, we can see various types of issues on the rock fall or wedge failure here, or after the blast, the various kind of the rock can spill onto the next bench here. So that has a broader implications there. The improper high wall alignment is another one, which is a cause of major uh, issues related to material either over digging or under digging, which means material left behind the bench face, or mining kind of beyond the bench face as designed here. So that causes another set of issues on the ore loss here. So the high wall alignment again is one of the conformance metrics that needs to be tracked after every excavation or blasting process. Another set of challenges that usually comes is from the blast-induced damages here, so which is typical is back break, which can reduce, which can instigate the slow failure issues. There are usually new cracks comes in, which is again the analysis of joints and the deep angle needs to be done. And then it opens existing discontinuities. So that has again a problem with kind of the thickening, kind of with the volume increase or loosening, which is again correlated to the ore loss. And then extension of the existing discontinuities, the line that is going in there. But there are other types of structural issues can come in, which is the micro cracks can develop, which can introduce block weakening as well, or the dislocation of rock blocks as well. On the excavation side, if the over digging and under digging is happening, that could result into potentially the ore loss by leaving a lot of kind of overbearing materials, which is a potential cause of a lot of dilution here. Uh, and on the geometry side, if there is a clear, a lot of the times there is always before the digging starts, there is always a plan of what is the dig line, what is the tolerance where the digging should not happen. But if that's the tolerance doesn't meet, the crest gets damaged, or the toe flare comes in, and those can also come into various issues such as rockfall. And to clean up this activity, there is again an extra rework is required. And then post excavation survey, that's why it's very important to maintain the true uh, resiliency of the structure of the face for the next blast. And that helps refine the design pattern for the not only the slope, but also the continuity of the structure of the face as well. So we look at what are the challenges here, but just kind of in a diagram way representing here, these are the day-to-day issues that can happen. Uh, this is the overbreak along the entire face, as you can see, that can cause a huge issues on the dilution side here. One here, the example is on the top of the bench. And then the underbreak at the toe can cause the floor issues, the hard diggability, equipment wear and tear potentially. Um, Overbreak at the toe, same issues, but more importantly, again, the ore loss, and overbreak at the crest and underbreak at the toe. So these are both scenarios here, which is again just almost a slow failure types of issues can happen here, or the structural damage here. So time for again another poll here. Would like to see the response is more on how often you are doing the design conformance and geotechnical analysis. So just launch the poll. Okay, so we'll give another 5 seconds since the answers are still coming in. Yeah, interesting responses. I think most of the responses are everybody is doing once a week, which is great. All right, we'll close the poll now. Thank you, everybody, for participating here. All right. So the next up is again, now we know that why there are challenges in the design conformance, and but it's a necessity that it has to happen in every operations, and looks like everybody is doing at least once a week here. But how you can do that more effectively? That's what we're going to cover in the next remaining 30 minutes here, and how AI use cases can be applicable here. So the examples or the use cases that I want to talk about in geotechnical AI are these three topics: high wall and slope safety, haul road assessment, and design conformance here. On the high wall safety side, there are now AI as a tool can be utilized to automatically check the face height, angle, catch bench width, and inter-ramp angle. Uh, but the crux of this entire data is identifying the crest and toe automatically. And it has reached the point where the AI can easily detect the crest and toe on the entire mine pit and identify easily the crest and toe, and that becomes the data for your other set of analysis, such as angle, inter-ramp angle, catch bench analysis, automated way. And it can draw automated cross sections as well based on your defined criteria to generate the area of interest that you are mostly looking on a weekly basis. So it can look into the prior survey, compare the next survey, compare the design data as well to start building these historical comparisons. Some examples here, which is correlating to in a visual way where the possible issues are. So you can define this tolerance range based on your site condition. If the bench height doesn't meet certain criteria, show those areas in red, or the angle doesn't meet certain criteria, show those areas in red. But you can also take it even a step further to identify the area of interest, to run more granular analysis, to identify the comparison of the different benches in those area of interest. So these histograms represent the analysis of different multi-level benches, and you can compare whether the top level bench to the bottom, to the mid, to the bottom, or how the height is consistent or not, or whether the inter-ramp angle is meeting the criteria or not there. So those analysis can be quickly activated once the crest and toe identification is done. It's simply just looking at the data here to analyze with your tolerance criteria. Another useful example here is the same data now can be utilized once this information is gathered Now, this data can be utilized to identify the slow failure risk factor analysis, which means a combination of the AI outputs, which are AI results, AI detected results on the kinematic or the rock mass analysis, and then the geophysics model to combine and predict the safety factor for different areas of your pit. So the high risk areas are shown in very red, dark red here. So this gives a quick indication on the same data. By the way, you're not collecting any other types of data. You have the same data, but now the analysis can be activated to understand what these risk factor areas are. More granular analysis can be done to recognize where these joints, orientation, bedding plane, dip angle, and strike directions are. So a true kinematic analysis can be done for the entire face, on a daily basis, and you can start building again the comparison of whether this joints is increasing or whether it's kind of changed direction there on the strike side, so that you have that understanding of the structure, and then you can import this data to your other design softwares to build or improve the mine design. The way it works is the AI detects a clusters of joints and planes, and that can be used to identify specific areas of interest as well. So not only does it is giving the rock mass information, but if I take this data and incorporate that into my mine planning process, that helps understand the better pit planning as well. Uh, on the geotechnical feature side, if we have the understanding of the different dip angle and dip direction, we know the position of bedding and floors. So it also identifies various different damage zone because it can understand thickness. The analysis is done on the 3D data. So it is actually have information of the true 3D structure. So it can really understand the infill thickness and the character of the structure as well, along with anyways the shape and spacing of the joint as well. We can incorporate the distribution of different major lithologies so you can understand and model the slow failure more accurately. But once you have the analysis that can be seen on a visual way, this can be taken further into an automated reporting here. So this reporting are done once analysis is ready, just fairly one click. It generates reports which has various types of information based on your tolerance that you have set, such as high wall height, angle, catch bench width into ramp. It is pulling for the entire pit, and it is giving you a distribution of, let's say, 37% of the pit is in 0 to 28%, 0 to 28 degree into ramp angle. So whether that is a good thing or whether do we need to do a course correction. So that gives a quick summary report that can be floated to all the stakeholders in a faster way. And it has other various types of granular information can be pulled in automatically here. Along with the visual representation of different red areas that we have identified, where those red areas are in the broader pit face, along with the specific, deviations that we have seen, whether it's in 75th percentile or whether the deviation is fairly large. Now we know just by looking at the reports instead of looking at the entire model there. So what benefits it comes? We looked in the beginning the challenges that we talked a lot about ore loss and dilution, as well as the safety side of the things. But again, just to summarize here, if you have this data quickly, more regularly. It can prevent wall failures, the over sterilization that usually comes, from these activities, which is blasting and excavation. But another one is the rework. You don't have to do a lot of rework on your mine planning or mine improvement side there. The next step is, a little bit touching more on the haul road assessment side. Same concept here. AI can detect the different features of the road automatically, such as grade distribution, width, berm height, undulations, super elevations. So what it does, it is bringing all this information again at your fingertips, and now you can pass it on to the operational team. And in this case, it can be related to the road maintenance or road design improvement. And what I mean by that is, if you know exactly at what geolocation XYZ the grade has issues, now we can pass this data to the fleet management system, or we can incorporate the TPMS or the fuel data on top of the AI data to see which side of the grade is burning more fuel, or where the tire wear and tear or the tire pressure was high. So a regular design update can help improve all these activities on the operational side, or improving the overall road performance. Looking at again on the haul road side, there are various visual information that can be garnered here on the grade side, crossfall side, along with the berm height side. But again, if you're only interested in the area of interest, you identify your area of interest and then continue to compare with survey with several surveys that you have in plan. Uh, Again, the same concept, the reporting can be automated here as well, which is looking at the overall mine pit where the issues are in a summary level. But then it can be also granularly, those areas can be identified where the issues are or where the focus area is as well. So what benefits that can come in from the regular haul road assessment using the geospatial data here is, if we know in advance there are grade issues, of course that can has a direct impact on the cycle times. But it can be also correlated to the reduction in the fuel usage, improvement on the tire life. If we know and if we can catch the various issues, the geometry issues, on the road side. But more importantly, if we know the different issues on the traffic management side as well, which is the road width understanding, so which can also prevent various road incidents that can come in. Let's dive more on the design conformance side. For that, we have the last poll for today here, so we'll kick that off.
I'm just conscious of time as well, Ravi. We do have some good questions. Coffee Yaboa, thank you for your questions. Do you want to address these just now, Ravi, while the poll is ongoing?
Sure. Yeah, what's the accuracy of this AI? So the AI is a continuous learning process. As it sees, from it's an aggregation of several different types of scenarios, and as it sees new scenarios, it relearns and readjusts the model. But what we have seen is, I never say that it can be 100% accurate. It will never be. But it is reaching the point where uh, it can be relied for every data sets, which means if you have a pit and you are doing the geotechnical analysis, you start there and then you will see the regular accuracy being improved on the same site again and again. But as a baseline, what we have seen is 80%, to 90% accuracy can be improved, can be achieved or at a starting base level.
And the question from Kofi Yeboah from Newmont, what will be the required geological and geotechnical inputs into the AI model to enable it to run the desired results?
Yeah, so on the geological model, so if we are running the slope modeling, so in that case, we would need the material information, rock mechanics information. But if we are just understanding the rock mass, then it just your drone data, which are high resolution imagery or a LiDAR data. This too would be sufficient to get the rock mass and kinematic information. But if you want to incorporate the slope modeling, then we would need rock mechanics and the rock material information as well. And then I think just like the satellite feed into the AI model, the satellite data can be also be incorporated, but the resolutions are not that up to a good level. So we have mostly relied on LiDAR and the drone data at the moment. All right, so we're done with the poll here. So thank you, everybody, again for participating. Very interesting responses here again. We'll continue with the last bit of presentation. So in terms of the design conformance, the first step is bringing your design data. So you have your as-built data. Now you're reconciling this on your pit, the as-built to the design. So the design data that the platform accepts is on one format, which is the DXF. As long as you have DXF, it matches, and then we can run the comparison here. And as you can see, most of the things are all automated here. As soon as you pass on the data, you can see the different analytics here, such as crest loss, toe flare, catch capacity, and various other metrics here that we, in the beginning, that we talked about why those are important to track, such as here the reconciliation part, the crest and toe loss here. So you can visually see where those crest and toe are deviating from the actual as design here and as built here. The catch bench here, so the effective catch capacity, the areas where are shown in the tolerance selection here is essentially for anything on the blue side here is anything above or under 5 meters. Show me the tolerance there. So those are the visualizations that you can quickly see, but that same information can also be imported into a larger report as well for better understanding. The next step is which is batter and bump compliance, looking at in the entire pit side where these angles, like so looking at kind of plus or minus like 20-degree differences are. So you can see at the entire pit level. You can set your old tolerance distances for this to visualize in a color-coded view here, in almost like a heat map for your entire pit, where this batter and bump compliance are not meeting. And then the overbreak and underbreak here as well, which is looking at, again, the wall performance more from the excavation side, which is over digging or under digging. You can quickly see where the overbreak, which means is showing in red, and the blue, which is underbreak here. But where it becomes really useful is taking this data and correlating to your geotechnical model, a structural model, and then the design process, and then the improvement on your mine planning operations there. So this data can be regularly updated, can be compared historically, can be compared with designs. So the value that comes out from the up-to-date design conformance is, of course, the compliance. You are maintaining your compliance that is required. It can be communicated to all these stakeholders on a regular basis the reports are already in one place. And then improving the mine designs, all this data that has been generated by AI can be imported to your design and planning softwares as well. So improving the mine designs and mining techniques, to minimize the ore loss. And then last but not the least, on the safety side, which is the pit stability issues can be easily tracked once we are doing regular design conformance with the as built data. So that concludes for today's session. We don't have a time for demo, but please do reach out if you are interested in demo. Rocket Mind team kind of will be happy to schedule that. I will hand it over to Barnaby here back. Thank you, everybody.
Thank you, Ravi, for the very informative presentation. I don't think we've got any other questions just now on the chat here. But if you just go to the next slide there, Ravi. If you would like to find out more about the Straos software and the service offerings, you're welcome to send a mail to hello@rocketmind.com, and a member of the team will gladly assist you. In South Africa, on the call, there's AJ and Hanu. So one of them will reach out to you, and for West Africa, it would be myself and Kwadjo. So I hope you found this webinar of interest today.